Welcome to the new Cyber Frontier, bringing you the latest news and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's new Cyber Frontier.
Hey, good morning, everybody, and welcome to New Cyber Frontier. I'm your host, Timothy Montgomery, and today we're here with David Kruger. Let's say that right, sir?
It's Kruger, like that Freddy guy. Only he's
gotcha, Freddy Kruger.
He's probably nicer than I am. So
yeah, I always say that because I always botch people's names so much, and it rolls off the tongue. But Kruger, gotcha, sir. And so we're kind of talking about the concept behind the conception of getting. What would you say it was? Just how data is being not necessarily encrypted or safeguarded or protected. But just how the market is really getting it wrong when it comes to really protecting data, right?
Yeah. We have a very contrarian view of what cybersecurity is and how it can be accomplished. And, we can certainly talk about that. The evidence for the correctness of our view, I think, is the last 20 years of where we've watched year-over-year increases in cybersecurity failures. So they're increasing in frequency and they're increasing in magnitude on a pretty predictable path because of the underlying mathematics. And we can explain that a little bit as well. And then we'll propose an alternate way of thinking about the problem that we think would be more fruitful.
Well, sir, if you would introduce yourself a little bit, what about a little bit of your background? So when we get in, everybody understands why of all people you come to the plate, really questioning these things and what you think is,
Okay. So I'm one of the co-founders of the company. I'm one of the co-inventors and patent holders for technology called software-defined distributed key cryptography. That's a product that we have. But my background for a couple of decades prior to getting in the IT business in 1999 was in safety engineering, and it's actually safety engineering that got us to think about the problem of cybersecurity differently. This is my fourth software startup. We've done one B2C, one B2B, and this is our second software developer tools company. So I've been kicking around in this world for about the last 22 years, but for 22 years or so prior to that, I was in chemical process and hazardous transport safety engineering.
I got some relatives to do that. So
yeah,
quite understandable. There's safety mechanisms.
We keep stuff from going boom.
Yeah, that's the best part, especially when it's going down the highway with you, right?
Yeah. Oh, yeah.
Yeah, transportation and the dot scenarios. My sister, she's a chemist. Been in disposal company for 20 plus years, and she talks about that a lot when we chat. So
there's a ton of safety engineering in general, and a particular kind of safety engineering called inherently safer design that maps to cybersecurity very nearly perfectly.
And you said something on here. I was looking at your LinkedIn page, and you were talking about the Internet Exploder going to retire soon. I always call it Internet Exploder, but that was something that was referenced from one of my coworkers in a class. I thought it was, and most students think it's funny because a lot of people like to use Internet Explorer. But you said it was retiring soon. That was a nice little tidbit. That June 2022, June 15th, something.
Yeah, I think
that was something that was said in there. And I thought that was interesting. You plug that in there.
You can call it IE or as we call it, a hole you can stick malware into. So,
It's interesting. Okay. So without further ado here, I'm going to go ahead and take a break. I know that we just got into this, but after about 5 minutes, so we got to do a little plug for our sponsors and take a brief pause here. And when we come back, we get further into this concept of where we're going to go with how to fix the issue, I guess you could say, right?
Yes, sir.
So, so we're going to take a break and hear from our sponsors. So we'll see you right after that. We'll get back to it.
Blockframe technology offers next-generation blockchain-managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. I'm your host, Tim Montgomery, and today's topic is more or less about the concept behind data protection and just where we're getting it wrong as far as the economics and the enterprise inner part workings of how this thing is starting to, I guess, define itself for future references. It's not necessarily about protecting everywhere the data goes, but protecting the data itself. And so with Dave Kruger, talking about an ingenious piece of software that's been co-invented by Dave here, about how with encryption, it looks like you could technically encrypt the data, tag the data, do all kinds of things to the data and have it flow with wherever the data goes. Is that correct?
Yeah, that's basically correct. So let me kind of roll the clock back to 10 years ago when we first started working on this problem and give you some of the sort of the safety-oriented thinking that came. That is the reason why we designed the things and we have the view of cybersecurity that we do. So when you're doing safety engineering, the first thing you do is you always do a root cause analysis, right? You want to find out not just what the symptoms of the problem are that you're having, but you want to keep on rolling backwards through the chain of causality till you find out what the actual root cause of the problem is that you're trying to remedy. And the reason that's so important is because if you can solve the root cause problem, typically it's a much broader, better solution, and it's a whole lot less expensive, right, to fix it at the root cause rather than treating all the symptoms that branch off of that root cause. So we look at data as inherently hazardous, and people are always surprised like that. You mean like a hazardous chemical? And we say, yeah, exactly like a hazardous chemical. So the first thing to get your head wrapped around is that data is physical. I'm doing this long series of articles for Forbes magazine that all start with this tag, the physicality of data. So when you're, holding your smartphone or a tablet or, you're sitting in front of a server or a desktop, laptop, whatever, there's no magic in it. It's all physics, right? Harry and Hermione and Hagrid don't live in your phone, right? So when a piece of software manufactures a piece of data, it manufactures a physical thing. Now, that physical thing is quantum small, that data object. But it's a pattern of ones and zeros, right? Binary that are applied, and you make some pattern of either magnetic particles or pits on a DVD or a pattern of wave, radio waves or light waves or something like that.
Right.
The important point is that it has a physical form and structure, right? And its behavior is absolutely predictable. So when the first digital files were digitized back in the early 50s at Bell Labs, right? They had this very simple 2-bucket construct for the data. You had the payload, right? The data that was digitized, this human usable information. Then it was laid down on tape, but they had to have metadata, and the metadata was basically still what we have today, right? The most basic form of metadata is just a name and address so that you can go and find it.
Yeah, it's a record-keeping process, right?
Yeah, so that's it, right? So here's your stuff, and here's where you can find it, right? So you can reuse it, you can edit it, you can do anything, and then stop.
Oh, yep.
So if you fast forward today till just about 70 years in the future, that's exactly the way most data is still made. And it doesn't matter if it's unstructured data or semi-structured data with tags or a database, structured data, it doesn't matter. The physical data object is still this 2-bucket construction. The problem is that anybody who gets access to that data object can pretty much just do whatever they want to with it. They can copy it. They can because of the internet, they can transmit it to anywhere in the world that they want to. They can alter it. They can delete it. They can, rename it. They can change the metadata. So that project, that object is completely uncontrollable once it's shared. And the easiest example, if I send you an email and I say, Tim, don't forward this to somebody else, or don't give the attachment to somebody else, or don't show it to X, Y, and Z, but you can show it to A, B, and C. Yeah. I have no way to control what you do with that.
Right. You have to trust
whatever you want to with it, right? I just have to trust you.
Right.
Right. So essentially what we recognized early on is that there is a third bucket that you have to be able to create. You need to be able to cryptographically bind a control layer to the data object itself. And that cryptographically bound control layer, right, has to have two basic types of controls. One, it needs to have authentication controls, right? And I'm talking about more than just user authentication. We'll circle back around to the authentication problem here in a second. But the second thing it does, let's just assume that this object is encrypted, right? That it's self-protecting, what we call self-protecting.
Yeah.
Once it's decrypted and it's ready to be used by the software, right? You need to have a set of controls that inform the software what it can and cannot do with the data. Because again, if I encrypt an email, for instance, or if it's got an encrypted attachment, you can't use it unless I also, do like a key exchange with you where you can use it. And at that point in time, again, it's the same problem, right? You can do whatever you want to with it. So what we realize is that you have to make the data objects themselves self-protecting and self-directing. And the way you do that is that by default, when an object is created, right, when the first time that you save it and every time thereafter, it needs to stay encrypted when it's in storage and it's in transit, right, and only be able to be decrypted by somebody you've done a key exchange with. So that part is pretty normal, right?
The integrity part.
Self-direction is that it needs to be automatic and it needs to happen 100% of the time, right? And it needs to be something that the user doesn't think about, that has no visibility. The user doesn't have to do anything. You can't rely on a connection. You don't have to rely on hardware. Your software is the thing that makes the digital object, the physical digital object. So it should be the thing that encrypts it, right? Yeah. It needs to be always encrypted unless it's decrypted momentarily for use by the software in order to be able to process it. And then when it is in that decrypted state, there need to be controls that accompany the data that inform the software what it can and cannot do. Right. So that's the basic construct. Now let's oppose that view to the defense in depth model. Right. All right. So we'll give you a simple a word problem, a math problem we can do in our heads. Right. So think about every vulnerability, hardware vulnerability, software vulnerability, poorly written code, insecure code. Yeah. Every person that touches a machine. Yeah. Every known vulnerability in the CVE index and all the ones that are not in the CVE index. Right? So think of those. Those are vectors, right, to the target. The target is always data. When you hear people say we have to protect our networks, my instant response is why? Somebody wants a network, they can go buy one. Go to Best Buy.
It's the data we got to protect.
You can get a deal. Cisco will help you out. You don't need to protect our networks because the goal of cyber attack is always either to steal, impede the delivery of data, or to adulterate the data, or to delete the data. Right? The target of the attack is always data. So you've got these different vectors to the target, right? And then you've got, for every vector, there are numerous instances of that vector, right? So if you want to get a sort of a domain of the possibility of cyber attacks, right? You multiply all of the instances of the vectors by the number of vectors, and you get the total attack surface, right? The total potential attack surface. Now start doing defense in depth. right? So first of all the possible defense in depths, you have to take off the ones that you can that are 0-day exploits, right? That nobody knows about.
Yeah,
that somebody knows about, or that nobody's built a defense for. Subtract those. Subtract for all the known good defenses that haven't been implemented because people don't have the budget or they don't have the manpower to do that. Subtract again all of the known defenses that aren't ever erected simply because people are apathetic, right? Right. Which is the bigger number, right? The total attack potential or the total defense potential? Well, the total attack potential is always going to be significantly larger than total defense potential. So as long as you have a consistent number of attacks on a broad enough spectrum, some of those attacks are going to get through.
Okay.
So now the argument for the defense in depth position is, well, if you use our WYSIWYG keen technology, right, we'll reduce the probability that an attack will succeed.
Right. You're mitigating.
Again, that's real good marketing speak, but it's really poor mathematics, right? What you have in the realm of cyber security, right, is the most asymmetric warfare we've ever encountered.
Yeah.
Right. So I'll ask you a question. You're the cyber defender.
Blockframe technology offers next-generation blockchain-managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Right? And I'm the cyber attacker. I'm the bad guy.
Yeah.
Right? You defeat my attacks 1,000,000 times. I only defeat your defenses once. Who won the game?
Technically, nobody.
No, I did. I won it fair and square. So if you defeat me 1,000,000 times and I defeat you once, I win the game.
I got you. Yeah,
right? So, you're right. So from a risk management standpoint, remember the basic risk management formula is probability times consequences, right?
Right.
Right. It doesn't matter how many tries I have to make. I only have to succeed once. And that once is entirely unpredictable. So when people when cybersecurity companies say, well, try our defense in depth approach and you're going to reduce your probability of having a successful cyber attack, I'm going to say, show me the math. And I will tell you right now, from a probabilistic risk assessment standpoint, which is what safety engineers like me do.
Yeah, that's normal, typical.
You have no idea whether it's going to actually reduce your probability of or your risk at all, right? And if you can't predict how the degree that it's going to reduce your risk, then you can't predict that it's going to reduce your risk at all.
That's true.
So all of this stems back to this construct. If we keep on having software make data that is by its nature uncontrollable, and all a cyber attacker has to do to win is to get access to that data so they can take control of it, perhaps you ought to do things on the basis of the cyber attack winning. Cybersecurity should be based on your credential. You still have to provide it. If your credentials are compromised, if the software is compromised, if the device is compromised, or if the user is compromised, that should be your base layer of design. Assume compromise because you can't stop it, and then build cybersecurity out from that point. Does that make sense?
Yeah, that makes sense. Total sense.
Yeah. So it's because you can't reliably or predictably keep bad guys from getting into your network or onto your devices or suborning your users through some sort of social engineering attack. It's just not possible.
Yeah, you're right. And protecting or self-defending, that's uniquely different too. When you talked about data and being able to
self-defending and self-directing. The other so there's two big problems. One is the way that software makes data, and the other one is the way that we think about authentication. All right. So anytime a computer performs work, there are always three actors involved. Right? There are no exceptions to this. Right? There's a user, there's an instance of software, and there's an instance of hardware. Right? I mean, is it possible for a computer to add 1 + 1 without a user saying, "Hey, add +1 and the software that's installed on hardware actually doing the math and producing the result?" No. I mean, you have to have all three.
Yeah.
But when we talk about authentication, right, the only thing that we talk about is user authentication. So think about every remote cyber attack, which is the vast majority of cyber attacks are remote. We authenticate a user and we say that's good, right? But if that cyber attacker has compromised credentials, they can take over control of a piece of software or a network, right?
Right.
But they're not doing it, they're doing it with using software and using hardware that are somewhere else, maybe in China or Russia or the Ukraine or North Korea, right? How can they get away with that? It's because the instance of software that they are using is never authenticated, and the instance of in the hardware, that instance of software is never authenticated. So we stop, for the most part, authentication at user authentication, and then we tell people incorrectly, right? Do do multi-factor, do biometric, all that stuff is good advice. But if you want to stop remote cyber attacks, which is like 99.9999% of cyber attacks, you also have to get into your head that anytime you connect to a computer, you should authenticate the user, the instance of software, and the hardware, all of which can be done cryptographically. We just don't do it, right? So if you have self-defending, self-directing data, and you fully authenticate and know with high reliability who's on the other line, because you've authenticated the user, be it human or machine, the instance of software, and the instance of hardware that it's running on, you will change the face of cybersecurity. If you do that, you can actually win instead of going backwards. But that requires a different way of thinking of the problem which I've just laid out. And I will tell you, it's immensely unpopular, what I just said. Because
change is always.
Well, no, it's unpopular because we have a cybersecurity industry right now that is, hundreds of $1 billion a year, or whatever, whoever's number you believe your industry worldwide, whose business model is built on not solving the problem.
Yeah.
Their business model is based on milking the problem, because if it ever got solved, they'd have to go find something else to do.
That's true.
So we have an industry whose promise is bogus. If you buy our stuff and you apply it, right, you're going to reduce your probability of getting a successful cyber attack, and that's not correct.
Yeah.
Right. So you ask yourself, think of any big player in the industry that makes an annuity income off of reducing probability, purportedly reducing probability. Do they actually want to solve the problem? Or are they going to be friendly to any technology that actually solves the problem? I think not.
Well, I would assume just from the top 10 attacks, they've never been solved. You would think some of this would have had solutions by now. They would have come off the top 10 coordinated attacks by most hackers. So the most common attacks, they've never, it seems like they haven't changed one iota from their abilities to use the same vectors to attack in the last 25 years or so since this minor attack.
Well, you keep on trying to plug all those holes, so you're trying to plug, in a practical sense, an infinite number of holes with a finite number of resources. Yeah. Either technical or human resources. That's a loser's game.
Yeah, right? It's a consistent monitoring session, and then you got a lot of mitigation, just consistently mitigating.
Yeah, so the technical term from the safety world for that kind of mitigation, right?
Yeah.
For after, post breach mitigation, the technical term in safety is closing the barn door after the horse is out. Right. And you say, oh, well, we learn from this, right? You learn from this, and that's legitimate. You do learn from looking at attacks, and you figure out how people got in.
Yeah.
My challenge would be, how useful is that knowledge if you know that it is mathematically impossible and growing worse as the number of connected devices grows, right? The number of vectors goes up.
Yeah.
Right. So the attack surface, the number of connections grows linearly. The attack surface grows exponentially. Right. That's just the math. That's just the math, right? That's just the way it is. And if that's the case, there is some utility in understanding how an attacker got in, but trying to plug these holes.
Yeah, consistently over and over.
Consistently and do it, in some way that you can actually reduce the probability of an attack being successful.
Like the Gopher game.
You're not going to happen. Not going to happen. Never going to happen. Mathematically impossible. And I at this point in time, I'm an old guy and a curmudgeon. I don't care who that aggravates, but that's just the way it is. And if somebody wants to gainsay me, well, they know how to get in contact with me.
Yeah, it sounds like the idea behind it. I certainly understand where the concept, why it's better off to protect the data by utilizing metadata and different factors and encrypting the data itself. So you're literally allowing that coupling of those different components to actually be delivered every time the data moves somewhere else. And forget about the vectors of the threat, because once you've done that, there is not really, you don't have to break those down in components protections. It's just data protection. Yeah.
So we do two things. We enable the encryption, the data to be encrypted automatically, regardless of, whether it's unstructured, semi-structured, or structured, right? It's just automatic. No user effort, no software developers don't need to be able to do anything. And this is an enabling technology. What we do fits into software, right?
It looks like you got
software developer tools. The other thing that we do is we provide this bucket of metadata, right, that says before you can use this, right, you've got to authenticate the user, the instance of software, and the device that's installed on. And that creates the capability of making a known universe of devices that you will allow to connect to your business. Right? That's work. That's a lot of work. But the alternative to doing that is what we have. Cybersecurity that's getting worse every year, and whose worseness, to coin a term, is going to get better. Is going to get worse exponentially as the number of connection grows.
Well, I think we're hitting it on the head here. We're at noon, for me anyway. You wanted a hard stop somewhere around here, I believe.
Yeah, about 12:05. I got to stop in 5 minutes.
Okay. So
does this make sense to you?
Yeah, it makes a lot of sense. I completely, when I started reading what you had on your site there, all those want to go out and take a look at the ABSCO, I think it's called.
ABSCO. I'm doing this articles for Forbes. Just Google my name in Forbes, and these are little 5-minute explainer articles, and they'll walk you right through it.
Yeah, and there was you guys did a little create self-defending data.
Self-defending, self-correcting data.
Yeah, so that was absolutely, broke it down pretty simple and sweet. It was a 1 minute little blast of information on how it couples the metadata and the emphasis of the roles and the encryption piece to the data. And so that way it can't be basically manipulated once it's been coupled. And then once it gets to wherever's place for integrity, and gets to be used wherever it is, it actually tells it what to do. So otherwise it can't be used that way. Otherwise it's basically set up to do these things and these things only. It's controllable factors that can't be enhanced or changed, which is interesting because I haven't seen it like that before. And it's right with the data. Is it with device or with user, that type of factor? So
at the moment you separate the data from its controls, whoever has access to the data can do whatever they want to with it. So, boom.
Yeah, and Forbes, you're doing a couple of series there. So what's the outcome of do you believe the outcome would be with these series that you've got going on?
We're just trying to get people educated. My mission with the Forbes article is to get people to think correctly about the problem. There's an old business guy whose name just went right out of my head. I can't remember the name because I've used this quote a million times. If you want, if you want to get the right answers, you've got to ask the right questions.
Yeah, no, there's no doubt about that.
And people, when it comes to cybersecurity, they ask, how can I treat the symptom rather than how can I cure the disease?
Yeah.
And so there's a lot of money. There's a lot of money in symptom treating, not so much in the cure. So
yeah, sounds like a different avenue, a different category. Healthcare we get into, it seems the same thing. Treating symptoms, not necessarily what might be the actual core issues and things.
Yep.
Same mindset there. So, well, sir, it's interesting to hear your take on just how that, what it means to actually protect data versus the other method.
Defense in depth, or defenseless in depth.
Yeah, defenseless in depth. Maybe starting to call that. I start talking to my own students. So
that's an accurate description.
Yeah, at this point, the way you're describing it, you're absolutely correct about it, because it does put a lot of holes in that concept, defense in depth, especially when there's we're consistently always being attacked. And you're right, you can't plug all the holes. You've got to pick and choose.
If you can't even know where all the holes are, and the worst thing is you've got the human element, right?
Yeah.
How are you going to fix that?
You're not.
You've got people with credentials in their head.
Yeah. So cybersecurity professionals know up front, if they try to take something like that on and told their C-suite they could fix a problem like that, you might as well pack it up. So.
Yep, I better get going. My other one's starting here. I got another session starting in 15 minutes, and I'll go.
Let me quickly close out. Thank you, sir, for being with us. And I hope to get a chance to talk with you later and see how things are going as we get down the road with your articles and stuff. Be interesting to see just what kind of information or feedback you get from those. So I'm your host, Tim Montgomery, and our guest, David Kruger. Was on with us today talking about data and how cybersecurity should be changing the way it looks at protecting data. Until next time, everybody have a great day, and we'll see you next round.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.